This video is on the objective, calculate the sample size required to estimate a population proportion with a given confidence level. This is number 2, a second video on a question related to this objective from your Newton Alta homework. So if you've already seen the number 1 video on this, you know what's happening. How to calculate, what's the minimum sample size I need to guarantee that a certain confidence interval is going to be within a certain amount, right, within a certain margin of error of the actual population proportion. Right. Okay, so again, if you're unfamiliar with this, want to see how it's done, look at their instruction, click on more instruction here, look at their videos, read their notes, read their examples. Hopefully that helps you. All right, suppose a clothing store wants to determine the current percentage of customers who are over the age of 40. How many customers should the company survey in order to be 90% confident that the estimated sample proportion is within 4 percentage points of the true population proportion of customers who are over the age of 40? All right, so notice no sample proportion was given, right? No p-hat was given. So let me refresh your memory here about the formula used for this. Now remember the margin of error formula when we're estimating a proportion? It was, this some z-score with alpha over 2 area above it times the square root of, the sample proportion times 1 minus the sample proportion divided by the sample size. And then I solved this for n, right? We're trying to figure out the minimum sample size required. And that ended up being n equals, that z-score squared times, p-hat times 1 minus p-hat, or, sometimes that was referred to as q-hat, divided by the margin of error squared. And then you round it up to the next highest integer, right? Making n as large as possible. All right. And round up. So here, they're talking a 90% confidence level. So that helps me find this alpha over 2, right? This z-score. I need to find the z-score there. Now, if 90% is the confidence level, the value of this alpha is the remaining 10%, or 0.1. And then the alpha over 2 would be 5%, or 0.05, right? So we're trying to find the z-score that has 5% above it. Right, what z-score in the standard normal distribution has 5% above it, and that's given to us in this little chart here that they gave us. See, z.05 is 1.645 standard deviations, right? So this is 1.645. I've got that. And I mentioned this in my first video. If a sample proportion isn't given, or if a previous proportion isn't noted, so if p-hat is not given, use a value of p-hat that will maximize n, that will give you the largest n possible, because the larger the sample size gets, right, the smaller your margin of error will be when you create a confidence interval. If p-hat is not given, use 50%, use 0.5 for p-hat. So I've got p-hat, and this would be 50% as well. You'd have two 50%s, 2.5s here. And then one last thing we were given, they said that we want this company, this store wants to be 90% confident that their sample proportion is within 4% of the true population proportion. So they would like the margin of error to be 4%. But remember, don't enter 4. 4 percentage points means 0.04, not 4. Right. So now I pop all those into my formula there. Now I have all the missing pieces. So n, the sample size, is going to be a 1.645 squared times 0.5 times 0.5 again. So I could have just written 0.5 squared divided by the margin of error they wish for, this 4%, right, 0.04 squared. And we're going to round that up. So let me punch this in the calculator. Let's get rid of this up here. All right, so we have 1.645 squared times, and then 0.5 times 0.5 is just 0.5 squared divided by the margin of error 0.04, 4 percentage points squared. And then bumping that up, that'd be 423. Okay, so they would need to take a sample of at least 423 customers in order to guarantee that a 90% confidence interval is going to be within 4%, that their sample proportion will be within 4 percentage points of the actual population proportion. They would need to take a sample of 423 people or more. All right, so looking back here, I know this is a multiple choice one. There it is, 423. All right, submit. Wonderful. And again, they go through the same calculation I went through here. They got Q hat instead of 1 minus P hat, but same thing. They do all the same stuff. So again, pretty simple. I feel again the hardest part is looking up a formula, figuring out, remembering what formula is being used, and then plugging in the correct numbers in the correct places. So yeah, hopefully this helps you when you're working on this kind of problem on that objective on your own. And thank you very much for watching.